Every mystery begins with a place. Ours begins in Sagittarius, a galactic crossroads, a junction where the impossible collides. This is where researchers have traced the origin of 3I-ATLAS, the very same patch of sky where, decades ago, the WOW signal tore through the silence. Coincidence? No. Far too precise. Far too deliberate. Something, or someone, may already be reaching for us. Stay with me. Because tonight we uncover why Atlas's path does not look random at all, and why 3I-ATLAS may have been listening the entire time, waiting, in silence. If this mystery has you hooked the way it has me, make sure to hit like and subscribe so you don't miss a single update as this unfolds in real time. Drop a comment with where you're tuning in from, what time it is there, and whether you believe we're getting the full truth about these shocking discoveries. And if you want to help this community grow, share this video on X, Facebook, Reddit, or even just in your group chats. You're the reason we can keep chasing stories like this, so thank you for having our back. Part 1. The shock opening. When astronomers traced the orbit of 3I-ATLAS backward through time, integrating its trajectory across millions of years of galactic motion, they expected to find a parent star system, some stellar nursery or disrupted planetary disk that had ejected this wanderer into the void. What they found instead stopped them cold. The object's trajectory, when rewound like a cosmic film running in reverse, pointed back to Sagittarius, the same constellation, the same patch of sky that gave us the most compelling evidence for extraterrestrial intelligence we've ever detected. The 1977 WOW signal. Not approximately the same region. The same region. The Archer's bow aimed directly at Earth. This is not how science is supposed to work. Coincidences happen, sure, but coincidences this precise, this laden with implication, make you wonder whether you're looking at random chance or something that was designed to be noticed. Three elements are converging here in a way that feels less like accident and more like choreography. First, an interstellar object, confirmed visitor from beyond our solar system, arrives from Sagittarius after a journey lasting potentially millions of years. Second, the strongest candidate SETI signal ever recorded, a 72-second radio burst so powerful and narrowband that astronomer Jerry Eman wrote "Wow" on the printout, came from Sagittarius in August 1977. Third, Earth itself has been broadcasting radio signals into space for nearly a century, and some of those signals have already reached stars in Sagittarius travelling outward at the speed of light, announcing our presence to anyone who might be listening. 3I-ATLAS was discovered in 2020, identified as interstellar based on its hyperbolic orbit, the kind of trajectory that can only mean the object isn't gravitationally bound to our Sun. It came from somewhere else, passed through our solar system, and will eventually leave again, heading back out into the galactic night. Unlike most comets, which follow elliptical orbits that bring them back periodically, interstellar objects are one-time visitors. They arrive, they leave, and if you don't study them during their brief passage, you lose the opportunity forever. This makes every interstellar detection precious, and every detail about their origins critical for understanding where they came from and what they might tell us about other stellar systems. The WOW signal remains unexplained nearly 50 years after detection. On August 15, 1977, at 11:23 p.m., the Big Ear radio telescope at Ohio State University detected a strong narrowband signal at 1,420 MHz, the hydrogen line, exactly the frequency that SETI researchers predicted extraterrestrial civilizations might use, because it's a natural wavelength that any technological species studying their universe would discover. The signal was so clearly artificial, so different from background noise, that it couldn't be dismissed as instrumental error or atmospheric interference. But it never repeated. Follow-up observations of the same region of sky found nothing. No subsequent detection has matched its characteristics. For nearly 5 decades it's hung in scientific limbo. Too compelling to ignore, too unrepeatable to confirm. Earth's radio bubble, meanwhile, has been expanding since we invented broadcast technology. Every television show, every radar ping, every radio transmission leaks into space, spreading outward in a sphere now roughly 200 light-years in diameter. That bubble encompasses thousands of stars, including many in Sagittarius. If technological civilizations exist around any of those stars, they've been receiving our signals for decades. They know we're here. They know we have technology. They could, theoretically, have been watching I Love Lucy episodes since the 1950s, analysing our radar signatures, tracking our military communications, building a profile of our civilization based on the electromagnetic fingerprint we've carelessly splashed across the galaxy. The convergence is what demands attention. An object arrives from the same direction as our most significant SETI detection. That direction happens to be one we've been broadcasting toward for a century. The timeline creates a feedback loop. Signals out, signal in, object in. It looks less like three separate coincidences and more like three acts of the same play, a cosmic exchange unfolding across decades and light years, with Earth as both sender and receiver, both the civilization reaching out and the civilization being reached. If Sagittarius is special, if it's more than just another constellation among 88 arbitrary star patterns humans have drawn across the sky, then we need to understand why. One possibility chills and excites in equal measure. What if Sagittarius isn't just a direction but a hub, a galactic crossroads where signals converge and probes monitor, where civilizations separated by unimaginable distances have established some kind of relay network, nodes positioned strategically to watch young technological species emerge and announce themselves? What if we've been signalling into a neighbourhood that was already occupied, already wired with infrastructure we don't yet recognise, already watching us with patience measured in geological time? This transforms 3I-ATLAS from an interesting astronomical curiosity into something far more significant. Not just a visitor, but potentially a messenger, a probe, a physical artifact of contact arriving exactly when and where it would most clearly connect to our own attempts at cosmic communication. The researchers who traced this orbit backward didn't expect any of this. They were doing routine analysis, the kind of computational work that happens constantly in astronomy. Take an object's current trajectory, integrate it through the galaxy's gravitational field accounting for stellar encounters and tidal effects. See where it might have originated. Most of the time, this yields results that fit existing theories. Comets trace back to the Oort cloud, asteroids to the main belt or Trojan populations, interstellar objects to stellar flybys that perturb them loose from their parent systems. But 3I-ATLAS defied these expectations. Its trajectory rewound to Sagittarius and then kept going, tracing backward through millions of years without finding a clear origin point, as if the object had always been travelling, as if it were placed on this path intentionally rather than ejected naturally. This creates an interpretive crisis. Either the object is so ancient that its origin has been scrambled by millions of years of galactic orbital mechanics, making it effectively untraceable, or something about its trajectory doesn't fit natural models. The first explanation is uncomfortable, because it means we're looking at debris potentially billions of years old, a fossil from stellar systems that might not even exist anymore. The second explanation is more uncomfortable because it opens the door to artificial origins, to the possibility that 3I-ATLAS's path was calculated rather than random, designed to pass through our solar system at this particular moment in human history, when we'd be just technologically sophisticated enough to detect it, and just curious enough to ask these questions. If the trajectory was designed, if some intelligence set this object on its course millennia or millions of years ago, timing its arrival for now, then the Sagittarius connection becomes less coincidence and more signature. It's saying, we heard you, we're responding, we're coming from the place you've been signalling toward, from the place that signaled you first. The WOW signal becomes not an isolated mystery but part one of a conversation. 3I-ATLAS becomes part two, and we're left wondering what part three looks like, whether it's already on its way, whether we'll recognise it when it arrives, whether we're ready for what contact actually means when it comes not as a dramatic announcement, but as subtle alignments that take decades to recognise and interpret. The shock isn't just that an interstellar object came from Sagittarius. The shock is that it came from Sagittarius at exactly the moment when we're sophisticated enough to trace orbits backward, exactly when we're asking whether we're alone, exactly when our own signals have reached deep enough into that region to plausibly trigger a response. The timing, the direction, the convergence of outbound and inbound messages, all of it suggests that we might not be discovering contact so much as recognising it. Finally, after it's been unfolding around us for years without our noticing, 3I-ATLAS might not be the beginning of something, it might be the continuation of a dialogue. We started decades ago without realising the universe was listening. Part 2. Orbital Forensics. Tracing an object's orbit backward through time is detective work on a cosmic scale. Astronomers start with the object's current position and velocity, measurements taken from multiple observations as it moves across the sky. They feed this data into simulations that model the gravitational influences of every significant mass in the galaxy: the Sun, planets, nearby stars, the galactic disk itself, even accounting for the cumulative tidal effects of dark matter distributed throughout the Milky Way. The simulation runs backward, calculating where the object would have been last year, last century, last million years, integrating through all the gravitational perturbations that would have affected its path. If the object originated from a stellar flyby, or was ejected from a planetary system, this backward integration should eventually bring it close to a star that could plausibly be its parent. The Gaia Space Telescope has revolutionized this work. Gaia Data Release 3 contains precise positions, distances, and velocities for over 1 billion stars. For the first time in human history, we can reconstruct the three-dimensional motion of our stellar neighbourhood across millions of years. We can see which stars were close to us in the past, which ones will be close in the future, which ones crossed paths with objects of interest. When 2I-Borisov was discovered in 2019, the second confirmed interstellar visitor, researchers used Gaia data to trace its origin. They found it came from the general direction of a young stellar association, a group of stars born together and still loosely associated as they drift through the galaxy. The match wasn't perfect, but it was plausible. Borisov was a pristine comet ejected from a planetary system during its formation, sent tumbling through interstellar space until it happened to pass through ours. 3I-ATLAS offers no such comfort. Researchers checked dozens of stellar encounters, running the integration backward looking for close approaches to stars that might have hosted the object once. They found nothing. No star came close enough to 3I-ATLAS's reconstructed path to be a plausible parent. Some encounters were marginally interesting, but ruled out by velocity mismatches. The object would have needed impossible acceleration to escape from those systems. Others were ruled out by timing. The encounters happened too recently to account for the object's apparent age and trajectory. The further back the integration ran, the more scrambled the orbit became, affected by galactic tides and cumulative perturbations from distant masses. Eventually, the uncertainties grow so large that you can't reliably say where the object was millions of years ago. This is unprecedented for an interstellar object. We expect these visitors to be traceable, at least in principle, because they came from somewhere. Stars eject comets and asteroids constantly during planetary system formation and evolution. Close encounters between stars scatter these objects, sending some into interstellar space while retaining others in bound orbits. Over billions of years, the galaxy should be full of these wanderers, drifting between stellar systems, occasionally passing through ours by chance. 2I-Borisov fit this model perfectly. 1I-Oumuamua, the first confirmed interstellar object discovered in 2017, was harder to trace but still plausibly natural, though its unusual characteristics sparked ongoing debates about whether it might be artificial. 3I-ATLAS breaks the pattern. Its orbit doesn't trace to anything obvious. This creates two competing explanations, and neither is comfortable. The first is that the object is extraordinarily old, ancient beyond our ability to reconstruct its history. If it's been travelling for billions of years, if it was ejected from a stellar system that has since drifted far from its current location, due to galactic orbital mechanics, then the trail is simply too cold to follow. The galaxy rotates, stars move in complex patterns influenced by spiral density waves and gravitational interactions, and over sufficient time, any connection between object and origin dissolves into uncertainty. We'd be looking at fossil debris, a relic from an era when the galaxy was structured differently, when the stars in Sagittarius occupied different positions, when even the concept of Sagittarius as a human-defined constellation wouldn't have made sense because Earth didn't exist yet. The second explanation is that the trajectory was never natural in the first place. If someone or something deliberately placed 3I-ATLAS on this path, calculating its route to pass through our solar system, then orbital backtracing wouldn't find a natural ejection event because none occurred. The object's path would have been determined by engineering, not gravity. This doesn't require faster-than-light travel or physics-breaking technology. It just requires patience and precision. Launch the object millions of years ago, aim it carefully accounting for galactic motion and stellar positions, let it coast on a ballistic trajectory requiring no further propulsion, and it arrives when and where intended. From our perspective, it looks like an interstellar visitor following natural orbital mechanics. But underneath, the mechanics were chosen, not random. Deliberate trajectory insertion is a concept that makes most astronomers deeply uncomfortable, because it's unfalsifiable without additional evidence. You can't prove an orbit was engineered rather than natural unless the object does something that natural objects can't do. Non-gravitational acceleration beyond what cometary outgassing explains. Trajectory corrections suggesting active guidance, signals or emissions that demonstrate technology. 3I-ATLAS hasn't done any of those things conclusively, though as we explored earlier, claims of unusual behaviour exist. What it has done is resist standard orbital reconstruction, pointing back to a region rather than a specific origin, arriving from a direction laden with significance for human SETI efforts, timing its appearance for an era when we're just barely capable of studying it properly. The forensics are inconclusive by design. If you wanted to send a probe to another civilization, you might deliberately choose a trajectory that looks natural at first glance, that doesn't scream artificial to casual observation. You'd disguise it as a comet or asteroid, something that wouldn't trigger immediate alarm or intensive scrutiny. You'd let it coast for millions of years, patient beyond human comprehension, because civilizations rise and fall, but physics is eternal. When it arrives, it looks like just another piece of space debris, interesting to astronomers but not immediately recognized as contact. Only when someone looks closely, when someone asks the right questions and notices the patterns, does the nature of the visit become clear. Or we're overthinking it. Space is full of old rocks. The galaxy is 400 billion stars and trillions of smaller objects drifting between them. Some of those objects will have untraceable origins simply because they're ancient, because they've travelled too long and too far for their history to be reconstructed with current data. The fact that 3I-ATLAS points towards Sagittarius could be meaningless. The fact that it resists orbital reconstruction could just mean it's older and more scrambled than 2I/Borisov. Assigning intent to what could be random motion is pattern-seeking, not science. And yet the pattern persists, begging to be noticed, demanding interpretation, even if interpretation means accepting that some coincidences are just coincidences no matter how loaded they feel. The dilemma sits at the centre of this investigation, like a black hole warping everything around it. Either 3I-ATLAS is ancient beyond reconstruction, a drifter so old that its origin story has been erased by time, or it's something else entirely, something placed rather than ejected, something guided rather than random. The orbital forensics can't distinguish between these possibilities because both produce the same observational signature, an object with no clear parent star, no obvious ejection event, tracing backward to a general direction rather than a specific place. What breaks the tie, what lets us choose between random and designed, will be everything else we learn about this object, everything beyond just its trajectory. The orbit points to Sagittarius. Now we need to understand what Sagittarius might mean. Part 3. The Sagittarius Neighbourhood. Sagittarius dominates our view of the galactic centre. When you look toward the Archer, constellation, you're looking through the densest concentration of stars in our galaxy, peering toward the supermassive black hole that anchors the Milky Way's rotation, toward the bulge where stellar populations crowd together in configurations impossible in our quieter spiral arm. This is the cosmic downtown, the metropolitan core where gravity runs strongest, and matter collects in extraordinary densities. Star-forming regions blaze with ultraviolet radiation from newborn stellar clusters. Ancient red giants, billions of years old, drift in orbits that have circled the galactic centre hundreds of times. The region is everything: nursery and graveyard, construction site and ruin, the most active and most ancient stellar populations coexisting in a space so crowded that from a planet in that region, the night sky might contain thousands of stars brighter than our brightest. This density makes Sagittarius a natural meeting point, a crossroads where trajectories from across the galaxy might plausibly intersect. If you wanted to position a monitoring station or relay node where it would have maximum exposure to passing civilizations, where the probability of eventually encountering another technological species was highest, the galactic center region would be the obvious choice. More stars means more planetary systems, means more chances for life and intelligence to arise. The region has been churning out stars for the entire history of the galaxy, meaning any civilizations that evolved there had a head start measured in billions of years. By the time humanity's ancestors were single-celled organisms barely learning photosynthesis, civilizations in Sagittarius could have been ancient, could have spread throughout the region, could have established infrastructure we're only now becoming capable of detecting. The statistical odds of 3I-ATLAS pointing towards Sagittarius by pure chance depend on how you frame the question. The sky contains 88 constellations of varying sizes. Sagittarius is large, covering a significant fraction of the celestial sphere, so any given direction has maybe a 5 or 10% chance of falling within its boundaries, depending on how you define the borders. That doesn't sound particularly unlikely. But when you add the wow signal, when you specify not just any constellation, but the constellation that produced the most significant SETI candidate ever detected, the odds tighten considerably. And when you add Earth's broadcast history, when you specify the constellation we've been inadvertently signalling for decades, the coincidence becomes harder to dismiss. You're not asking, what are the odds of pointing toward any constellation? You're asking, what are the odds of all these elements aligning toward the same constellation? And that's a much more constrained question. Sagittarius has appeared in human mythology for thousands of years as the archer, the centaur with bow drawn, aiming toward the heart, of the Scorpion constellation that lies nearby. Ancient civilizations saw this asterism and constructed narratives around it. A hunter, a warrior, a guardian positioned at the edge between the known world and the cosmic beyond. They couldn't have known they were looking toward the galactic center. They couldn't have known the supermassive black hole lurked there, or the dense stellar populations, or the star-forming regions blazing with energies that would one day be visible through telescopes humans hadn't yet imagined. But they sensed something, encoded significance into that direction, made it a focal point for stories about power, danger, and the unknown. Modern science cautions against over-interpreting coincidences, and this caution is healthy. We evolved to see patterns. Our brains connect dots even when no connection exists because false positives were less lethal to our ancestors than false negatives. Better to see predators in every shadow than to miss the one that's real. This cognitive bias means we'll find significance in Sagittarius even if it's just another direction, among infinite possible directions, even if the wow signal was a natural radio burst from a magnetar or some other astrophysical source we haven't identified yet, even if 3I-ATLAS traces to that region purely by chance. Scientists push back against this tendency constantly, demanding evidence before accepting extraordinary claims, requiring that patterns survive rigorous statistical analysis before being elevated to the status of discoveries. But conspiratorial framing has its own logic. Too many coincidences piling up starts to look less like coincidence and more like signal. At what point does astronomically unlikely become probably not random? Where's the threshold between healthy skepticism and willful blindness to patterns that deserve investigation? If 3I-ATLAS came from any other direction, we probably wouldn't be having this conversation. If the wow signal had originated from Orion or Andromeda instead of Sagittarius, the interstellar object's origin would be just another data point. The convergence is what creates urgency, what transforms orbital forensics from academic exercise into potential first contact scenario, and the convergence keeps getting tighter the more layers you add. The galactic disk rotates, and Sagittarius sits in the direction of rotation, the direction toward which our solar system is moving as we orbit the galactic center. This makes it a natural collision point for objects approaching from that direction, and our own motion through space. If you wanted to intercept our solar system, launching from the galactic center region and timing the arrival for our passage would be geometrically favourable. The relative velocities work out, the trajectories align naturally. An object coasting from Sagittarius toward our current position wouldn't need complex manoeuvring. It would just need careful timing, a launch calculated to put it in our path at the right moment. This doesn't prove design, but it removes one objection. Why Sagittarius specifically? Because that's the direction from which interception is most straightforward. Astronomers studying 3I-ATLAS continue to run simulations, refine the integration, check for close approaches to stars in the Gaia catalogue. Some are searching for parent systems. Others are exploring the ancient trajectory hypothesis, trying to model what the galactic environment looked like millions or billions of years ago when the object might have been ejected. Still others are quietly entertaining the artificial hypothesis, not publishing about it because that's career suicide without extraordinary evidence, but running the calculations privately, asking what a deliberately inserted trajectory would look like and whether the data fits. The community is split, careful, aware that this could be the most significant discovery in human history or a spectacular waste of time on an object that's just a rock. Sagittarius waits at the centre of this uncertainty, a direction that means nothing and might mean everything. The constellation itself is arbitrary, a pattern humans drew connecting stars that have no physical relationship to each other, that just happen to lie along the same line of sight from our perspective. But the galactic centre is real. The dense stellar populations are real. The fact that our most compelling SETI signal came from there is real. And now an interstellar object arrives from the same direction, untraceable, resistant to standard analysis, timing its appearance for an era when humanity is just sophisticated enough to notice the pattern, and just curious enough to wonder whether patterns sometimes mean what they seem to mean. If Sagittarius is a hub, a waypoint, a monitored region where young civilizations are watched and evaluated, we're about to find out. And the finding might not be dramatic. It might be exactly this. Slow realization dawning that the coincidences aren't coincidental, that we're being noticed, that the Archer's arrow has been in flight for millions of years, and we're only now seeing it arrive. Part 4, 1977, A Strange Alignment. August. 1977 was an extraordinary month for humanity's relationship with the cosmos, though we didn't understand that at the time. Two events occurred, separated by days, that would later seem less like coincidence and more like symmetry. Two notes in a larger composition we're still trying to hear clearly. On August 20th, NASA launched Voyager 2, a robotic probe designed to study the outer planets and then continue into interstellar space, carrying a golden record encoded with images, music and greetings from Earth in 55 languages. The spacecraft's trajectory would eventually take it toward the constellations Sagittarius and Parvo, diving below the plane of the solar system, heading into the galactic south, carrying our message outward at 35,000 miles per hour, a pace that feels fast by human standards, but is glacially slow by cosmic measures. 5 days earlier, on August 15th, the Big Ear radio telescope detected the WOW signal. The timing creates a bookend effect that's impossible to ignore once you see it. Earth sends a physical probe outward, aimed towards Sagittarius, and almost simultaneously we receive what remains the strongest candidate radio signal for extraterrestrial intelligence coming from Sagittarius. Message out, message in, launch, and detection. The symmetry would be poetic if it weren't so unsettling, if it didn't suggest that maybe, just maybe, these events weren't independent. Maybe someone or something was watching, noticed our preparations to send Voyager, and responded immediately with a signal timed to arrive just before the launch saying, "We see you, we're here, we're in the direction you're sending your probe." This interpretation requires extraordinary timing, but timing is what technology provides. If a monitoring system existed in Sagittarius, if it had been watching Earth for decades or centuries, it would have observed our technological development. Radio broadcasts starting in the 1920s, television spreading globally in the 1950s, increasingly powerful radar and deliberate SETI transmissions in the 1960s and 70s. It would have calculated how long its own signals would take to reach Earth at the speed of light. If it decided to respond to our emergence as a radio-capable species, it would have transmitted years or decades earlier, timing the arrival of its signal for maximum impact, for a moment when we'd be actively thinking about interstellar communication, when we'd be most likely to notice and investigate rather than dismiss. Voyager 2's golden record represents humanity's most deliberate attempt at cosmic communication before that point. The record contains 116 images showing Earth's diversity, mathematical and physical concepts, human anatomy, animals, plants, architecture, technology. It includes 90 minutes of music from cultures worldwide. It has greetings in 55 languages plus whale songs, because we included Earth's other intelligent species even if they can't build spacecraft. The record is analog, playable with the cartridge and stylus included on the spacecraft, designed to last billions of years in the interstellar environment. We encoded instructions for playing it on the record's cover, using universal physical constants to define timing and dimensions, so any technological species could decode it, even without knowing anything about human culture. The assumption was that Voyager would drift for millennia or millions of years before encountering anyone. The golden record was a message in a bottle thrown into an ocean so large that recovery seemed effectively impossible. We did it anyway, not because we expected results, but because the act of creating the message mattered to us. It forced us to think about what we'd want to say if we could talk to the cosmos, what we'd choose to represent humanity when we had only a few megabytes of data space and a single 12-inch record. The choices were political, philosophical, artistic. What music defines us? What images? What languages? The record is as much a time capsule of 1977 human consciousness as it is a message to aliens. Fast forward to 2025. Voyager 2 is now approximately 150 astronomical units from the Sun, still functional though its power supply is failing, still sending back data about the interstellar medium, the region of space between stars that no human-made object had entered before. It's travelling at roughly 3.1 astronomical units per year, which works out to about 10,000 miles per hour relative to the Sun. At that pace, it'll take roughly 40,000 years to travel 1 light year. The nearest stars are over 4 light years away. Voyager won't come close to another stellar system for hundreds of thousands of years. By the time it does, humanity might not exist. The probe will outlive us, carrying our message into a future where Earth is ancient history. But here's the thing. Voyager is heading towards Sagittarius and Pavo, and 3I-ATLAS came from Sagittarius. One object outbound, one inbound, both connecting to the same region of space. The objects won't meet, obviously. 3I-ATLAS has already passed through our solar system and is heading back outward. Voyager is taking a completely different trajectory, but symbolically, metaphorically, they're counterparts. Our message going out, their probe coming in, if probe is what it is. The paths cross in conceptual space even if they never intersect physically. We're sending an artifact of our civilization into the cosmos, and the cosmos might have sent one back. A reply not in radio waves, but in physical form. An object that rewards close study with implications that grow stranger the more you examine them. The 1977 alignment creates what some researchers call year zero of cosmic communication. Before that year, we were transmitting radio and television signals but passively, accidentally, not deliberately trying to communicate with anyone beyond Earth. Voyager changed that. It made our intent explicit. We were reaching out, saying hello, hoping someone might be there to hear. And almost simultaneously, we received the wow signal. A hello back, possibly, if that's what it was. Decades later, 3I-ATLAS arrives from the same direction, completing a trilogy. Signal out, signal in, object in. Each element can be explained individually as natural or coincidental. Together, they form a pattern that's harder to dismiss. What happens when outbound Voyager and inbound Atlas cross paths in deep time? They won't, physically, but the civilizations or intelligences associated with them might. If 3I-ATLAS is a probe, it sent information back to wherever it came from, possibly years or centuries ago depending on how communication works. That information includes data about our solar system, our planets, and if it has any capability to detect electromagnetic emissions, our technology. The civilization receiving that data would know we're here. They'd know we're at approximately 1970s technology level based on Voyager's launch and the Golden Record. They'd have a profile of us, our capabilities, our intentions, our willingness to reach out. And they'd have to decide what to do with that information, respond openly, continue monitoring silently, send additional probes, or ignore us as too primitive to engage with yet. The strange alignment of 1977 suggests we might already be in dialogue without recognizing it. The wow signal wasn't a fluke, it was a response. Voyager wasn't just us talking to ourselves, performing an empty gesture of hope. It was the opening move in an exchange that's still unfolding, that will continue unfolding across timescales humans struggle to conceptualize. 3I-ATLAS is the next move, the physical artifact following the radio signal. Proof that someone or something is out there and interested enough to send hardware, not just electromagnetic whispers. And we're left wondering what the next move will be, whether we're ready for it, whether first contact is something that happens suddenly or gradually, across decades and centuries, in pieces that only make sense when you step back and see the whole pattern. Part 5. The opening dilemma. We're left suspended between two explanations for 3I-ATLAS, and the choice between them shapes everything that follows. On one side sits the natural explanation. Interstellar objects are common, perhaps thousands passing through our solar system every year, too small or dim to detect. Debris from planetary formations scattered throughout the galaxy by gravitational interactions. 3I-ATLAS is just one of these, notable because we spotted it, because we're getting better at finding such objects, but ultimately just a rock. Its trajectory towards Sagittarius is coincidental. Its apparent untraceability is because it's ancient, or because our models aren't sophisticated enough yet. The wow signal connection is pattern-seeking, humans finding meaning where only randomness exists. This explanation is conservative, fits established physics, requires no new assumptions about alien civilizations or interstellar probes. It's the explanation most scientists default to because extraordinary claims require extraordinary evidence, and we don't have that evidence yet. On the other side sits the engineered explanation. 3I-ATLAS is an interstellar probe, deliberately sent to our solar system, possibly part of a larger network of monitoring devices scattered throughout the galaxy. Its trajectory was calculated, not random. Its timing is intentional. Its connection to Sagittarius and the wow signal is real, components of a communication strategy we're only beginning to recognize. The probe is disguised as a natural object because that's what you'd do if you wanted to observe without causing panic, if you wanted to let the target civilization gradually discover you rather than announcing yourself dramatically. This explanation requires accepting that another technological civilization exists, as interstellar travel, or at least interstellar probe capability, has been monitoring us, and chose this moment to make contact subtle enough that we have to work to see it. The probe hypothesis isn't new. It's been around since 1960, when physicist Ronald Bracewell proposed that advanced civilizations might use autonomous probes rather than radio signals for interstellar communication. Radio travels at light speed, but dissipates with distance, requiring enormous power for interstellar ranges. Probes travel slower, but carry more information, can adapt to local conditions, can watch and wait for civilizations to develop technology before revealing themselves. A galaxy-spanning network of Bracewell probes could create an interstellar internet, nodes positioned strategically throughout the galaxy, monitoring star systems, waiting for signs of intelligence to emerge. When a probe detects radio signals or other technosignatures, it might activate, begin signaling, perhaps even approach the system to study the new civilization more closely. What would an alien probe actually look like? Probably not a sleek spacecraft with obvious technological features. That would be inefficient and attention-grabbing. More likely, it would be disguised as something natural, a comet, an asteroid, a piece of space debris indistinguishable from the millions of natural objects drifting through any stellar system. The disguise serves multiple purposes. It avoids triggering defensive responses from the target civilization. It allows the probe to operate unnoticed for centuries or millennia while the civilization develops. It ensures that when contact happens, it happens on the probe's terms, when the civilization is ready, when they've demonstrated sufficient technological sophistication to recognize the probe for what it is rather than mistaking it for a rock. SETI researchers have long argued that advanced civilizations would likely prioritize stealth over flashiness. Broadcasting powerful radio signals requires enormous energy and announces your presence to any potential threats within listening range. Sending probes is quieter. The probes can observe passively, gathering data without revealing themselves until they choose to. This is the dark forest hypothesis. The idea that the galaxy might be full of civilizations keeping quiet because drawing attention is dangerous. If that's true, then first, contact wouldn't be a dramatic arrival of obvious spacecraft. It would be subtle, gradual, something you might miss if you weren't paying careful attention. It would look a lot like what we're seeing with 3I-ATLAS, an object that seems natural at first glance but reveals strangeness under scrutiny, connections to historical signals and patterns that suggest intention rather than randomness. The relay node concept takes this further. Instead of individual probes operating independently, imagine a network where each probe communicates with others, creating a web of information exchange across interstellar distances. probes positioned every few hundred light years throughout the galaxy, each monitoring its local neighbourhood, each reporting back to the network when interesting things happen. Stars forming, planets coalescing, life emerging, civilizations developing technology. The network wouldn't need faster-than-light communication. Radio signals travelling at light speed between nodes would be sufficient for a civilization or meta-civilization patient, enough to think in timescales of millions of years. Earth would be one system among millions being monitored, our development tracked, our signals logged, our emergence as a technological species noted and filed. The Fermi paradox asks, if the galaxy is billions of years old and life is common, where is everybody? Why haven't we seen clear evidence of alien civilizations? One answer is that we have seen evidence, we just didn't recognize it. We interpreted probes as comets, signals as natural radio bursts, patterns as coincidences. We assumed contact would be obvious, that aliens would announce themselves clearly, that first contact would look like the movies with dramatic arrivals and unambiguous messages. But what if contact is happening right now, has been happening for decades, and we're only just starting to piece together the clues? What if 3I-ATLAS, Oumuamua, the WOW signal, and a dozen other anomalies we've dismissed or explained away are all part of the same phenomenon, nodes in a network we're finally becoming sophisticated enough to detect? This is where the dilemma becomes existential, rather than just scientific. If 3I-ATLAS is natural, we continue as we have been, alone in the universe, or at least alone in our corner of it, searching for signals that may never come, building narratives about cosmic loneliness. If it's engineered, everything changes. We're being watched. We're part of a larger structure we didn't build and don't control. Our signals didn't disappear into empty void. They were received, analysed, responded to. The WOW signal wasn't a mystery to be eventually explained by natural astrophysics. It was someone saying hello, testing whether we'd notice, whether we'd respond. And 3I-ATLAS is the follow-up, the physical artifact that rewards investigation with progressively stranger implications the deeper you look. The conservative position is to maintain skepticism until definitive proof arrives. Most scientists occupy this position because it's methodologically sound. You don't overturn established understanding based on ambiguous evidence and compelling patterns. You wait for smoking guns, clear signals, obvious artifacts, repeatable observations that can't be explained naturally. The problem is that if contact is deliberately subtle, if whoever sent 3I-ATLAS wanted us to figure it out gradually, rather than being hit with undeniable proof, we might never get that smoking gun. We might get exactly what we're getting, layers of strangeness that accumulate into a pattern, recognizable to those paying attention, but deniable to those who prefer conventional explanations. The radical position is to accept the probe hypothesis provisionally and see where it leads. This doesn't mean believing without evidence. It means treating the hypothesis as worth investigating seriously, allocating resources to test it, looking for additional data that might confirm or refute it. If 3I-ATLAS is a probe, it might have done things that natural objects don't do, trajectory corrections, signals we missed because we weren't looking at the right frequencies or times, responses to our observations or transmissions. Reanalyzing existing data with the probe hypothesis in mind might reveal patterns that were dismissed as noise when we assumed everything was natural. This approach risks wasting time and reputation on a hypothesis that turns out false, but it also risks being the ones who recognize first contact when it's actually happening. The middle position, the one that feels most honest, is to acknowledge genuine uncertainty. We don't know what 3I-ATLAS is. The data allows both natural and artificial interpretations, the Sagittarius connection, the WOW signal timing, the orbital untraceability. All of these increase the probability that something interesting is happening, but they don't prove it. We're in the uncomfortable space between detection and confirmation, between seeing something and knowing what we've seen. This is where science happens, in the tension between pattern and proof, between observation and interpretation. And this is where we have to stay, honestly, until more data arrives. But staying in uncertainty doesn't mean staying inactive. It means watching closely, monitoring the object as it moves outward from our solar system, looking for additional signals or anomalies, preparing for the possibility that we're witnessing the most significant discovery in human history, while also preparing for the possibility that we're overinterpreting natural phenomena, because we want cosmic companionship so badly we'll find it in random noise. Both preparations are necessary. Both possibilities remain real. And the question of what 3I-ATLAS actually is will be answered not by proclamation but by patience, by the slow accumulation of evidence, by continued observation and analysis, and that either confirms the probe hypothesis or explains away the anomalies until only the natural interpretation remains standing. If it's a relay, if 3I-ATLAS is part of a network monitoring young civilizations throughout the galaxy, then the message isn't in any single observation or data point. The message is the network itself, the fact of being watched, the realization that we emerged into a galaxy that was already organized, already connected, already humming with intelligence we couldn't detect until we developed sufficient technology. That message is both thrilling and terrifying. It means we're not alone, but it also means we're not unique. It means the universe noticed us, but we don't know yet whether that's good news or a warning. It means the conversation started decades or centuries ago, and we're only now recognizing that someone's been talking to us all along, patient as stone, waiting for us to learn the language, waiting for us to realize that the Archer constellation isn't just stars humans connected into a pattern, but a real crossroads, a real hub, a place where messages converge and probes are launched and young civilizations are tested to see if they're ready to join something larger than themselves. The opening dilemma frames everything that follows in this investigation. Natural or artificial, coincidence or design, alone or watched. The questions don't have answers yet, but they have implications that cascade through every observation, every analysis, every attempt to understand what 3I-ATLAS means, and whether it means anything at all. And as we move deeper into the evidence, as we examine composition and age and cosmic choreography, we'll keep returning to this fundamental uncertainty because it's where honest inquiry lives, in the gap between what we want to believe and what we can prove, between the patterns we see and the patterns that actually exist. Part 6. Composition Mysteries. When the James Webb Space Telescope turned its infrared sensors toward 3I-ATLAS, during the object's passage through the inner solar system, astronomers expected to see spectral signatures similar to 2I/Borisov, the pristine interstellar comet that visited in 2019. Borisov showed exactly what you'd expect from a comet that formed around another star. Water ice, carbon monoxide, carbon dioxide, organic compounds in ratios matching solar system comets, closely enough to confirm that planetary formation follows similar chemistry everywhere. It was exciting because it was normal, because it proved that the processes happening in our stellar nursery weren't unique, that comets forming around distant suns look and behave like comets here. 3I-ATLAS didn't cooperate with those expectations. The spectroscopy revealed an unusually high carbon dioxide to water ratio. Most comets are primarily water ice with smaller amounts of other volatiles mixed in. 3I-ATLAS showed the inverse pattern, lots of carbon dioxide, relatively less water. This isn't impossible naturally. Comets that formed in colder regions of their parent protoplanetary disk, farther from their star where temperatures allowed carbon dioxide to freeze but were still warm enough that water remained less abundant, could develop this composition. But it's unusual, rare enough, that finding it in the handful of interstellar objects we've studied raises questions about whether we're seeing a genuine oddity or evidence of something else. The coma, the cloud of gas and dust surrounding the nucleus as the object sublimates, appeared compact and structured. Normal comets develop large, diffuse comas as solar heating turns ice into gas that flows outward, pushed by radiation pressure into the characteristic tail. 3I-ATLAS's coma was smaller than expected for its brightness, suggesting either unusual sublimation physics or a nucleus with different thermal properties than typical comets. Some researchers noted that the coma's shape and density fluctuations looked almost regulated, as if the outgassing was being controlled rather than occurring naturally wherever solar heating was strongest. This observation is disputed, difficult to confirm from ground-based telescopes, and hasn't appeared in peer-reviewed literature, but it's part of the growing constellation of details that don't quite fit standard models. Comparing 3I-ATLAS to its interstellar predecessors reveals a spectrum of strangeness. 1I/Oumuamua remains the most anomalous. It showed non-gravitational acceleration, pushing it slightly away from the Sun beyond what gravity alone would predict. The best natural explanation is outgassing, jets of sublimating ice providing tiny amounts of thrust. But Oumuamua showed no visible coma, no tail, no spectroscopic evidence of outgassing. Harvard astronomer Avi Loeb proposed it might be artificial, possibly a light sail damaged or defunct, pushed by radiation pressure in a way that mimicked powered acceleration. The astronomical community largely rejected this, arguing that natural explanations, however stretched, were more plausible than jumping to alien artifacts. The debate continues unresolved because Oumuamua left our observational range before we could study it thoroughly. 2I/Borisov was refreshingly normal after Oumuamua's weirdness. It looked like a comet, behaved like a comet, had chemistry matching cometary models. It confirmed that at least some interstellar objects are exactly what they appear to be: debris from planetary formation, ejected during the chaotic early days of stellar system evolution. Its normality was scientifically valuable, proving that the baseline assumptions about interstellar objects being natural were sound. But that normality also makes 3I-ATLAS's differences more pronounced. If most interstellar comets are like Borisov, why isn't ATLAS? What makes this one different? The debate over artificiality hinges on defining what evidence would be sufficient. Avi Loeb argues that we should consider artificial origins as a serious hypothesis when natural explanations require adding multiple and likely factors. If you have to invoke unusual composition plus a typical outgassing plus suspicious timing plus orbital anomalies, maybe the simpler explanation is that the object isn't natural. Mainstream astronomers counter that alien probe is never the simpler explanation because it requires accepting that extraterrestrial intelligence exists, has interstellar technology, and chose to visit our solar system, all assumptions far more extraordinary than natural physics producing unusual but possible outcomes. This is fundamentally a debate about priors, about what you consider more likely before examining evidence: rare natural phenomena or alien visitors. A hybrid possibility occupies middle ground: a natural comet modified by engineering, a Trojan horse probe disguised in actual cometary material, rather than purely artificial construction. This would explain why 3I-ATLAS shows some comet-like behaviour, sublimation and coma formation, while also displaying oddities that don't fit pure cometary models. The core might be technology, instrumentation, perhaps even a dormant intelligence, wrapped in a shell of ice and rock gathered from its system of origin, or accumulated during millions of years of interstellar travel. From outside, it looks natural enough to pass casual inspection. Close study reveals the anomalies, but those anomalies are ambiguous, interpretable as either weird chemistry or deliberate design depending on your perspective. This hybrid model has fictional precedents, but scientific logic. If you're launching probes to explore or monitor other stellar systems, camouflage makes sense. Approaching a planetary system with an obviously artificial object might trigger defensive responses from emerging technological civilizations. They might attempt to intercept or destroy the probe out of fear or curiosity. Better to look harmless, to blend in with natural debris, to let the target civilization study you without realizing they're being studied back. The technology would be deep inside, shielded by meters of ice and rock, only revealing itself through subtle behaviors that someone would have to be looking for specifically to notice. 3I-ATLAS's compositional oddities could be exactly that. Subtle tells, fingerprints of technology visible to those analysing carefully but deniable as natural variation to those who prefer not to see. The chemical anomalies matter because they're measurable, reproducible data points that don't rely on an interpretation of ambiguous patterns. Either the carbon dioxide to water ratio is unusual or it isn't. Either the coma structure matches natural sublimation models or it doesn't. These are questions that can be answered with better data, more observations, refined analysis. The problem is that 3I-ATLAS is already leaving, moving outward beyond the range of our best instruments, and we didn't prioritise intensive study during its passage because we didn't realise how important it might be. We treated it as another interstellar visitor, interesting but not urgent, worth studying but not worth dropping everything to observe continuously. If it is artificial, if the compositional anomalies are evidence of technology, we may have missed our best chance to prove it. What haunts researchers who take the artificial hypothesis seriously is the possibility that the fingerprints of technology are there in the data we already collected, hiding in spectra we haven't fully analysed, visible in light curves we dismissed as noise, waiting for someone to look at them with the right question in mind. Most astronomical data goes under-analysed. Telescopes generate far more observations than research teams have time to process thoroughly. Data sits in archives for years or decades, before someone revisits it and finds something the original observers missed. 3I-ATLAS's composition data exists. It's in JWST archives, in ground-based telescope records, in amateur observer logs. The question is whether anyone will take the time to reanalyze it, looking specifically for signs of artificiality, or whether it'll remain filed as unusual but probably natural, needs more study. Until the object is too far away for follow-up observations and the question remains forever unresolved. Part 7. The Interstellar Cemetery. If 3I-ATLAS is ancient, if its orbit has been scrambled by millions or billions of years of galactic motion to the point where we can't trace it to any parent star, then we might be looking at something profoundly sad. Debris from a civilization that no longer exists, a probe still functioning long after its makers died, wandering the galaxy on momentum and programming older than human civilization, older than humanity itself, older possibly than complex life on Earth. This is the orphaned probe hypothesis, and it carries existential weight that pure natural explanations don't. A rock is just a rock, tragic only in the pathetic fallacy we project onto it. But a machine outliving its creators, still executing commands from minds that became dust billions of years ago, that's genuine tragedy on cosmic scale. The thick disk of our galaxy contains its oldest stellar populations, stars that formed within the first few billion years after the Milky Way coalesced from the primordial gas of the early universe. These stars are metal poor, formed before enough supernovae had enriched the interstellar medium with heavy elements, before planetary systems like ours with rocky worlds and complex chemistry were common. Some thick disk stars are 12 billion years old, nearly as ancient as the universe itself. If 3I-ATLAS originated from that population, if it was launched by a civilization that evolved around one of those ancient stars, it could easily be untraceable by now. The parent star might have drifted thousands of light years from where it was when the object was launched. The civilization might have been extinct for eons. This creates the concept of galactic archaeology, studying the ruins not of ancient human civilizations but of alien ones, parsing the artifacts they left behind to understand who they were, what they built, what they hoped to accomplish. Earth's archaeology reconstructs cultures from pottery shards and burial goods. Galactic archaeology would reconstruct civilizations from derelict probes, ancient satellites still orbiting dead worlds, ruined infrastructure on planets whose atmospheres blew away when their stars went nova. We haven't found any of this yet because we haven't looked carefully enough, because we're only now developing instruments sensitive enough to detect such artifacts, because we don't know what to look for or where. But statistical arguments suggest they should exist if technological civilizations are common on billion-year timescales. The cosmic graveyard hypothesis extends this. The galaxy is littered with defunct technology from civilizations that rose, flourished, and fell across billions of years. Most of it is unrecognizable, degraded by radiation and micrometeorite impacts until it's just strange metallic debris indistinguishable from natural asteroid composition. Some of it might still be functional, running on power sources that last geological epochs, continuing missions long after their purpose became meaningless. Probes drift through interstellar space, occasionally passing through stellar systems, photographing planets, recording data that goes nowhere because the receivers no longer exist. This is the ruins of ruins, contact not with living intelligence but with its ghosts, with the machines it left behind when it vanished. The parallel to human artifacts is inescapable. Voyager 1 and Voyager 2 will outlive humanity. In 1 billion years, both probes will still be drifting through interstellar space, their electronics long dead from radiation damage, their power sources decayed to inactivity, but their physical structures largely intact. The golden records will be unplayable, the aluminum surfaces degraded, but recognizable as manufactured objects to anyone who finds them. If another civilization encounters Voyager in the distant future, they'll be discovering our ruins, evidence that we existed, that we built technology, that we sent messages into the void hoping someone would receive them. They won't meet us. They'll meet our ghost, our artifact, the message we sent to a future we won't see. If 3I-ATLAS is an ancient probe, it might be our Voyager equivalent from someone else's civilization. They launched it with hope and purpose, programming it to explore, to gather data, to perhaps return or transmit findings back to them. But the timescales defeated them. Travel between stars is slow. Even at a tenth the speed of light, crossing the galaxy takes 1,000,000 years. Most civilizations probably don't last that long. Biological species evolve into something different. Technological societies collapse or transcend. The probe continues because it doesn't know how to stop, because its programming is simple. Keep going, keep recording, keep executing the mission until power fails or catastrophic damage ends function. And so it wanders, ancient and alone, occasionally passing through systems like ours where new civilizations are just emerging, where young species look up and wonder what this strange object might be, never guessing it's older than their world. This raises the chilling question of whether the interstellar objects we're discovering are actually dead technology rather than natural debris. One, I/Oumuamua's weird acceleration, could be a derelict probe's damaged propulsion system misfiring. 2I/Borisov might be an old probe whose exterior was so worn by interstellar travel that it accumulated enough ice and dust to look like a natural comet. 3I-ATLAS's compositional oddities could be remnants of manufacturing, traces of artificial materials mixed with accumulated natural matter after millions of years of exposure to interstellar gas and dust. We'd never know because we lack the resolution and proximity to examine them closely enough. We see them from millions of miles away, record their spectra and trajectories, and classify them based on limited data that natural and artificial origins might produce similar signatures for ancient objects. The implications are profound if this hypothesis is correct. First contact wouldn't be with living aliens, but with their debris field, with the junk they left behind as they spread through the galaxy and eventually died out. We'd be exploring a graveyard, cataloguing the dead, trying to understand vanished civilizations from their trash. Second, it suggests the Fermi paradox has a dark answer. Civilizations are common enough that their ruins accumulate, but they don't last long enough to make direct contact with each other. The galaxy is full of intelligence on timescales too slow for individuals to meet. Species rising and falling across millions of years, occasionally glimpsing each other's artifacts but never having conversations, never exchanging ideas in real time. We're all just passing notes to the future, hoping someone reads them eventually. Third, it means the ruins we're finding might be billions of years old, making them the oldest artifacts in the universe, more ancient than Earth itself, older than any structure natural or artificial in our solar system. 3I-ATLAS could be the oldest constructed thing humans have ever examined, a machine from an epoch when our sun was still forming, when the planets were coalescing from protoplanetary disk, when Earth was molten rock slowly cooling under constant bombardment. The civilization that built it might have evolved, flourished, and vanished before complex life arose here. Their entire history, rise and fall, might fit in the gap between Earth's formation and the first single-celled organisms. And their probe is still going, still executing its mission, carrying data that will never be downloaded because the receivers are dust. The galactic archaeology perspective reframes our search from "are we alone?" to "who came before us?" It accepts that intelligence is common, that technological civilizations arise regularly across billions of years of galactic history, but that direct communication is impossible because the timescales don't align. By the time we detect their signals or find their probes, they're gone. By the time our signals might reach someone, we might be gone too. The galaxy is full of messages travelling between extinct senders and receivers who will never exist. We're embedded in this temporal graveyard, adding our own artifacts to the collection, contributing to the archive that future civilizations will discover millions of years from now, when they develop their own astronomy and start asking the same questions we're asking. If 3I-ATLAS is a ruin, then studying it becomes an act of remembrance, honouring a civilization we'll never meet by trying to understand what they built and why. The compositional data, the trajectory, the timing, all of it becomes archaeological context, clues about who they were and what they valued enough to launch into eternity. And we become the first humans to encounter them, even if encounter means only examining their debris, even if contact is one-way communication across billions of years. Us receiving a message they sent before our species existed, before our planet was habitable, before our sun ignited and began its long burn that will eventually consume the inner planets, and leave the outer solar system cold and empty, except for whatever artifacts we manage to scatter beyond its reach, before our own civilization joins theirs in the galactic archive of extinct intelligence. Part 8. The SETI Mirror. Earth has been accidentally broadcasting its presence to the cosmos for approximately 100 years since the invention of radio technology in the early 20th century. Every AM radio transmission, every television broadcast, every radar pulse leaks into space at the speed of light, spreading outward in an expanding bubble, now roughly 200 light-years in radius. This bubble encompasses thousands of stars, including multiple candidates in Sagittarius, the galactic center region where stellar densities are highest, and where, statistically, the probability of technological civilizations arising is greatest simply because there are more stars, more planets, more chances for the rare conditions supporting intelligence to align. The signals we've sent aren't uniform or coherent. Early radio was weak, easily, drowned by stellar noise beyond a few dozen light-years. Television broadcasts are stronger but encoded in formats that change every few decades as technology evolves, making them difficult to decode without knowing the specific modulation schemes we used in each era. Military radar is our brightest emission, powerful pulses transmitted at frequencies and intensities that cut through background noise, designed to track missiles and aircraft with precision, but equally effective at announcing our presence to anyone monitoring radio spectrum within our light cone. These radar installations have been operating since the 1940s and 50s, creating the strongest techno-signature of human civilization visible from interstellar distances. If we calculate which stars in Sagittarius have already been reached by our earliest radio emissions, the numbers are both exciting and unsettling. Stars within 100 light-years of Earth would have received signals from the 1920s and 30s, weak broadcasts but potentially detectable with sufficiently sensitive instruments. Stars within 50 light-years would have received our stronger television signals from the 1950s and 60s. Anything within 25 light-years has been bombarded with modern telecommunications, GPS satellites, radar, and deliberate SETI transmissions we've sent toward potentially habitable star systems. Sagittarius contains multiple stellar populations at all these distances. Our signals have already reached them. If civilizations exist there with detection capability, they know about us. The timing creates a feedback loop that's hard to ignore. The WOW signal was detected in 1977. If it was a deliberate transmission rather than natural astrophysical phenomenon, it came from roughly Sagittarius's direction, though pinpointing precise origin is impossible, because Big Ear's antenna resolution was broad. If the signal was a response to our presence, the civilization sending it would have needed to receive our emissions, recognize them as artificial, decide to respond and transmit back. Light-speed communication means round-trip time equals twice the distance. If the source was 25 light-years away, they'd have received our 1950s broadcasts in the 1970s, plenty of time to detect us and respond before we detected them in 1977. The possibility that WOW was a reply, an acknowledgement of our presence, transforms it from unexplained mystery to first successful exchange in human-alien communication. We whispered accidentally through our normal use of radio technology. Someone heard, recognized the whisper as evidence of intelligence, and whispered back deliberately, choosing a frequency and modulation we'd recognize as significant, as potentially artificial. The signal's brevity makes sense in this context. They weren't trying to send complex information. They were saying hello, confirming, reception, demonstrating their presence. The fact that it never repeated fits too. Once they confirmed we heard them, once they established the connection, they went silent, waiting to see what we'd do next. What we did next, unfortunately, was mostly nothing. We logged the WOW signal as unexplained anomaly. We tried to find it again, failed, eventually filed it as fascinating unsolved puzzle. We didn't mount a comprehensive response because we couldn't be sure what we'd heard or where it came from exactly. SETI protocols were unclear then about whether and how to respond to potential detections. The scientific community was divided about whether deliberately transmitting to potential extraterrestrial intelligence was wise or reckless, whether it announced our presence to potentially dangerous unknowns, or whether staying silent was more dangerous because it meant remaining ignorant of cosmic neighbours who might already know about us anyway. This debate continues today, unresolved, paralysing our response capabilities. But if the WOW signal was them saying hello, and we said nothing back, they might have decided to send something physical instead. Radio is fast but limited. You can transmit information at light speed, but you can't be sure the recipient understands or responds. A probe is slower but more versatile. It carries instruments, computing power, potentially AI sophisticated enough to adapt to local conditions. It can study the target system in detail, confirming what radio observations suggested. This civilization is technological, they're emerging, they might be ready for contact or at least ready to know they're not alone. 3I-ATLAS, arriving decades after the WOW signal, fits this interpretation. The signal was Phase 1, hello. The probe is Phase 2, detailed study. Phase 3 might be direct communication, two-way exchange, mutual understanding, assuming we recognise what's happening and respond appropriately. The SETI mirror concept suggests that searching for extraterrestrial intelligence and being found by them might be the same process viewed from different angles. We've been broadcasting for a century, creating techno-signatures visible to anyone with our level of technology or better. Any civilization monitoring their local stellar neighbourhood, watching for signs of new technological species emerging, would have detected us by now if they're within our broadcast radius. We're not hidden. We're not silent. We announced ourselves loudly, accidentally, and anyone listening knows we're here. The question isn't whether we've been found. The question is what happens next, whether the civilizations that found us choose to reveal themselves, whether they're watching and waiting to see how we develop, whether first contact is something they control or something that happens mutually. The poetic framing is that we sent whispers, technological toddlers babbling into the cosmic dark without really understanding what we were doing, and the cosmos whispered back. The WOW signal was acknowledgement, proof that someone heard, that the galaxy isn't empty or silent, that intelligence exists out there and noticed us. 3I-ATLAS is the follow-up, the next step in a conversation we barely recognise we're having, a physical message following the electromagnetic one, designed to be studied closely, to reward investigation with progressive revelation. First it looks natural, then compositionally odd, then suspicious in timing and trajectory, then finally, if we dig deep enough, potentially recognisable as artificial. This is contact as teaching tool, as test, as gradual disclosure that lets us discover the truth at our own pace, rather than being overwhelmed by sudden undeniable proof. If 3I-ATLAS is the physical reply to our accidental broadcasts and their deliberate WOW response, then we're in the middle of a three-part exchange. We signalled accidentally, they signalled deliberately, they sent hardware to study us. What's our next move? Do we try to communicate with the object as it leaves our solar system, transmitting toward its trajectory, hoping it contains receivers and intelligence that can decode our attempts at message? Do we launch a probe to intercept it, trying to rendezvous for close study, though the speed and distance make that mission nearly impossible with current technology? Do we wait for more objects, more signals, more evidence that this is real and ongoing rather than isolated coincidence we're overinterpreting? Or do we do what humanity does best? Debate endlessly, disagree about interpretation, let institutional caution and scientific skepticism prevent decisive action until the opportunity passes and we're left wondering what might have happened if we'd been bold enough to assume contact was real and act accordingly. The mirror shows us ourselves as we appear to others, loud, curious, technological, emerging into galactic awareness without really understanding what that means or who might be watching. The mirror also shows us that we've been seen, that our presence has been noted, that we're part of a larger cosmic community whether we recognise it or not. The question is whether we're ready to look in that mirror and accept what we see, whether we can move past the fear and uncertainty to embrace the possibility that we're not alone, that we never were, that the galaxy has been watching and waiting for us to develop enough to join the conversation that's been happening around us and above us and through us across billions of years of galactic history. Part 9. The Shadow Theories. Beneath the official narratives of interstellar object discoveries and SETI detections runs a dark current of speculation. Claims that intelligence agencies and black-budget programs have been tracking unusual objects in deep space for decades. That 1I/Oumuamua wasn't the first interstellar visitor, but simply the first, one they couldn't keep secret. That our telescopes have detected numerous anomalous objects whose data was classified before reaching the scientific community. These claims exist in the shadowy space between conspiracy theory and whistleblower allegation, difficult to verify, easy to dismiss, but persistent enough that they deserve examination if only to understand what people believe is being hidden, and why. The allegations typically follow a pattern: defense-related telescopes, the ones tracking satellites and space debris to prevent collisions and monitor potential threats, occasionally detect objects with trajectories that don't match anything in their catalogues of known satellites, rockets, or natural objects. These detections trigger investigation. Scientists analyse the data, calculate orbits, determine whether the object originated from Earth or arrived from elsewhere. When the conclusion is elsewhere, when the trajectory is clearly hyperbolic and interstellar, the data gets classified. The official record shows nothing. The researchers involved are bound by security clearances and non-disclosure agreements. The public never learns that an unidentified object passed through our solar system. Proponents of these theories point to the sudden official acknowledgement of UAPs, unidentified aerial phenomena, by military and intelligence agencies as precedent. For decades, the official position was that UFO reports were misidentifications, hoaxes, or delusions. Then in 2021, the Pentagon released reports confirming that trained military observers had recorded objects performing maneuvers beyond known aircraft capabilities, that these reports were taken seriously, that investigation programs existed. The narrative shifted overnight from "these don't exist" to "these exist, but we don't know what they are." If governments can keep UAP investigations secret for decades before gradually acknowledging them, why not interstellar objects? Why not signals? Why not evidence of extraterrestrial intelligence detected and archived away from public awareness? The motivation for suppression would be multiple: preventing public panic, maintaining strategic advantage if the objects or signals contain exploitable technology or information, avoiding diplomatic complications if different nations detect different things, buying time to understand what's happening before making announcements that can't be walked back. Contact with extraterrestrial intelligence is arguably the most significant event in human history. Governments might reasonably decide that revelation should be controlled, gradual, manage to minimize social disruption, and maximize strategic benefit. This logic is sound, which makes the conspiracy theories harder to dismiss out of hand than typical paranoid fantasies. Secrecy around first contact might be genuinely justified by those maintaining it. The reports of missing comets and unpublished orbital anomalies are harder to track, because they involve absence rather than presence. Astronomers occasionally observe objects that don't get catalogued, that disappear from follow-up observations, that show up in preliminary data but never make it to published literature. Sometimes this is because the observations were errors, instrumental artifacts, misidentifications of known objects under unusual conditions. But sometimes objects genuinely vanish from tracking databases, their orbits showing brief appearances before gaps that suggest either they broke apart, which should leave debris clouds we'd detect, or they change trajectory in ways natural objects can't, or the data was deliberately removed. Proving this pattern requires access to classified databases, which researchers outside intelligence communities don't have. The allegation that 3I-ATLAS is part of a larger catalogue of suppressed interstellar detections fits this framework. If defence telescopes have been tracking unusual objects for years, 3I-ATLAS might be one they couldn't keep secret because too many civilian observers detected it independently, because its brightness and trajectory made it impossible to hide. The earlier objects, dimmer or faster or on trajectories that brought them through regions of sky less monitored by amateur astronomers, could have been logged and classified before civilian science became aware. We'd be seeing only the tip of the distribution, the objects too obvious to suppress, while a larger population of detections remains locked in military and intelligence databases, unavailable for scientific analysis. Cultural parallels to UFO secrecy are strong and unsettling. The pattern of official denial followed by gradual acknowledgement, followed by limited disclosure while maintaining that nothing definitive is known, creates exactly the information environment where conspiracy theories thrive. People know they're not getting the full story. They see the gaps, the contradictions, the slow retreat from absolute denial to qualified admission. This breeds distrust and speculation. Whether or not actual suppression is happening, the perception that it might be happening shapes how people interpret ambiguous events like 3I-ATLAS. They assume hidden data, assume classified analyses exist, assume the public story is a sanitized version of more complex and disturbing truth. Mainstream scientific rebuttal of these theories focuses on practical difficulties of maintaining such secrecy. Thousands of astronomers worldwide monitor the sky. Data gets shared internationally. Papers get published in peer-reviewed journals accessible to anyone. Keeping discoveries secret would require coordinating suppression across multiple nations, institutions, and research communities, all of whom have more incentive to publish discoveries than hide them, because publication is how scientific careers advance. The conspiracy would need to be impossibly large, involving too many people across too many organizations with too many conflicting interests. Most scientists consider this logistically implausible, but limited suppression isn't implausible. You don't need to hide everything from everyone. You need to identify the most sensitive data, the detections that clearly indicate non-natural origins or extraterrestrial technology, and classify that narrow subset while allowing normal scientific publication of everything else. Most interstellar objects would be published normally because most are probably natural. The few that show clear artificial signatures get flagged, investigated quietly by cleared personnel, and filed in archives the broader scientific community never accesses. This creates a two-tier system: public astronomy studying natural phenomena, classified astronomy studying potential techno-signatures and artificial objects. The public system publishes papers and discovers comets. The classified system tracks something else entirely. Whether this actually happens remains unproven and probably unprovable without leaks or official disclosure. What's certain is that the speculation exists, shapes how many people interpret events like 3I-ATLAS and the WOW signal, and creates demand for transparency that official institutions struggle to satisfy without either revealing classified material or being accused of cover-ups. The shadow theories might be wrong, might be paranoid pattern-seeking finding malice in normal institutional secrecy around defense-related observations, or they might be partially right, might be glimpsing a reality that a few cleared scientists know but can't discuss, a reality where we've detected multiple interstellar probes, where the WOW signal was just one of many signals we've logged and classified, where first contact already happened and got filed away in databases we'll only access decades from now when secrecy restrictions expire or political calculations change. The cover-up angle works as narrative hook because it transforms passive investigation into active opposition. We're not just trying to understand what 3I-ATLAS is, we're trying to uncover what authorities know and aren't telling us. This creates urgency, conflict, the satisfying feeling of seeking truth against resistance. Whether the resistance is real or imagined matters less narratively. Part 10. Cosmic Choreography. The three elements converge with timing so precise it feels choreographed rather than coincidental. Outbound message, inbound signal, inbound object. Voyager 2 launched in August 1977, carrying humanity's golden record towards Sagittarius. The WOW signal arrived weeks earlier from Sagittarius, strongest candidate for extraterrestrial communication ever detected. 3I-ATLAS appears decades later from Sagittarius, compositionally unusual, orbitally untraceable, arriving exactly when humanity has developed technology to study interstellar objects seriously. Each element individually could be random. Together they sketch a pattern that suggests someone or something is coordinating responses to our presence, timing interventions for maximum recognizability while maintaining plausible deniability. The cosmic relay hypothesis proposes that what we're seeing isn't coincidence but infrastructure, a network of monitoring nodes positioned throughout the galaxy, watching star systems, detecting when technological civilizations emerge, responding according to protocols we don't yet understand. These nodes might be ancient, placed millions or billions of years ago by civilizations that have since transcended, vanished, or evolved beyond recognition. Or they might be actively maintained by a meta-civilization, a galactic community so patient and long-lived that monitoring young species across millennia is routine maintenance rather than extraordinary project. The nodes wait, silent and patient, until techno-signatures appear. Radio broadcasts, nuclear detonations, atmospheric pollution, orbital satellites. When the signature crosses some threshold indicating genuine technology, rather than natural phenomena, the node activates. Activation might proceed in stages. Stage 1. Passive observation intensifies. The node collects detailed data about the emerging civilization's technology, culture, behavior patterns. Stage 2. Initial signal. A brief transmission, enough to be noticed by those paying attention, but ambiguous enough to be dismissed by skeptics. This is a test. Does the civilization notice? Do they respond? Do they take the signal seriously, or file it as unexplained anomaly? Stage 3 depends on the response. If the civilization shows they're watching, shows they're curious, the node sends physical hardware, a probe that can be studied up close, that rewards investigation with progressive revelation, that serves as both message and message delivery system. The WOW signal fits Stage 2 perfectly. It was brief, 72 seconds, exactly the duration you'd expect for a signal designed to be detected but not decoded, noticed but not understood. It came from the hydrogen line frequency, 1.42 GHz, exactly where SETI researchers predicted artificial signals might appear, because it's a natural wavelength any technological species would discover. The signal was strong, orders of magnitude above background noise, impossible to miss if your telescope was pointed the right direction at the right time, and it never repeated, which makes sense if its purpose was confirmation rather than communication. They were saying, "We see you, we heard your broadcasts, we're here." One ping, then silence, waiting for our response. We didn't respond coherently because we weren't sure what we'd heard. The scientific community debated whether the signal was artificial or some unknown natural phenomenon. SETI protocols were unclear about whether and how to transmit back. The political and social implications of confirming extraterrestrial intelligence paralysed decision-making. So we did nothing decisive, just continued our normal broadcasts, continued developing our technology, continued launching probes like Voyager into interstellar space without realising we might already be in dialogue with whoever was listening. Decades passed. We forgot about the WOW signal except as historical curiosity, unexplained mystery that occasionally gets mentioned in SETI literature but doesn't drive active research. Then 3I-ATLAS arrives, Stage 3, physical proof, hardware we can analyse, an object whose strangeness rewards scrutiny. If this is choreography, it's patient choreography, operating on timescales that span human generations. The signal in 1977, the probe arriving in 2020, detected and studied through 2025. 48 years between contact attempts, time enough for an entire generation of humans to be born, grow up, and begin careers in astronomy and astrophysics. The delay makes sense if the monitoring system is interstellar, if signals and probes travel at light speed or slower, if the orchestrating intelligence understands that emerging civilizations need time to develop technology and psychological readiness for contact. Why Sagittarius as the hub? Multiple reasons suggest themselves. The galactic center region is the densest stellar environment in the Milky Way, maximizing the probability that monitoring nodes positioned there will eventually detect emerging civilizations. The region is geometrically central, equidistant from many spiral arms, making it an efficient relay point for communication between civilizations scattered throughout the galaxy. The supermassive black hole at galactic center provides enormous energy sources that advanced civilizations might harvest for power. And the region is obvious, astronomically significant to any species that develops telescopes and studies their galaxy structure. If you wanted to establish a meeting point, a place where multiple civilizations would naturally look and eventually establish presence, galactic center is the obvious choice. The galactic internet concept extends this. Imagine not isolated monitoring nodes, but a connected network, nodes communicating with each other via radio or laser or some physics we haven't discovered yet, sharing data about detected civilizations, coordinating responses, maintaining a living database of galactic intelligence that updates continuously as new species emerge and old ones fall silent. Earth's detection by the nearest node triggers notification throughout the network. Other nodes adjust their monitoring. Resources get allocated. Decisions get made about how to respond, whether to respond, what protocols apply for civilizations at our development level. We're added to the catalogue, marked as active monitored system, queued for eventual direct contact when we're ready. This sounds like science fiction, but it's logically consistent with what we observe if we accept that the coincidences aren't coincidental. It explains why the WOW signal came from Sagittarius. That's where the nearest monitoring node is positioned. It explains why 3I-ATLAS traces to the same region. The node deployed it, or the node network deployed it, sending physical hardware to supplement the radio signal. It explains the timing. The network operates on protocols that dictate response schedules based on target civilization development metrics. It explains the ambiguity. Contact is deliberately gradual, giving us time to adjust, to develop, to become psychologically and technologically ready for direct interaction. Compare this to human internet architecture. Most users never think about the infrastructure. Servers, routers, fiber optic cables, satellites, all the hardware making communication possible. They just know that sending an email works, that websites load, that data flows. From ground level, the internet feels like magic. Only specialists understand the physical systems enabling it. A galactic internet would be similar. Civilizations use it without necessarily understanding its full architecture. They detect signals, receive probes, eventually learn to access the network themselves once they develop sufficient technology. But the network itself is ancient, maintained by someone or something with resources and patience beyond what young civilizations possess. We're at the stage of receiving emails without yet understanding how email works, without access to the protocols and infrastructure enabling communication. If probes are nodes in this network, then 3I-ATLAS isn't a visitor but a local installation, something positioned in our solar system to monitor us more closely, to gather data unavailable through distant radio observation. The WOW signal was a handshake packet establishing connection, confirming the link. 3I-ATLAS is the router, the local node, the hardware that enables ongoing communication between us and the larger network once we figure out how to use it. This reframes the search for extraterrestrial intelligence from "are they out there?" to "how do we access the network we're already part of?" The signals aren't coming from distant civilizations. They're coming from infrastructure in our own stellar neighborhood, placed here long ago or recently, waiting for us to develop enough to recognize it. This raises the enormous question: are we already inside a communication network we don't understand? Have we been for years or decades or longer, receiving data we interpret as noise because we don't know the encoding? Are there protocols, handshakes, access methods that would let us tap into galactic conversation if only we knew what to look for? The possibility is simultaneously exciting and humbling. Exciting because it means we're not alone, we're not isolated, we're embedded in something larger and older than ourselves. Humbling because it means we're the newcomers, the primitives, the species just figuring out that the conversation has been happening around us all along and we weren't sophisticated enough to join it. The choreography, if that's what this is, continues. 3I-ATLAS is leaving our solar system now, heading back into interstellar space. We didn't intercept it. We didn't communicate with it definitively. We studied it from distance, debated its nature, published papers arguing about composition and trajectory. Maybe that was the test. Would we recognize it? Would we ask the right questions? Would we treat it seriously or dismiss it as another comet? Our response, or lack of response, gets logged somewhere, added to the profile of humanity that some network node maintains, and based on that response, decisions get made about what happens next, whether we get more obvious contact or whether we're left to develop further before the next stage begins. The choreography is patient. The universe has time. The question is whether we're watching closely enough to see the dance we're already part of. Part 11. AI and the Cosmic Hunt. In 2025, machine learning algorithms achieved something human. Astronomers had been attempting for decades. They found patterns in stellar motion data that suggested previously undetected close encounters between the Sun and nearby stars millions of years ago. Artificial intelligence systems trained on the Gaia Data Release 3 catalogue containing positions and velocities for over 1 billion stars, integrated orbital trajectories backward through time, accounting for gravitational perturbations from the galactic disk, spiral arm passages, and encounters with molecular clouds. The AI identified stellar flybys that human analysts had missed, close approaches within 1 or 2 light years that could have scattered objects from the Oort cloud, or ejected material from passing stellar systems into trajectories that eventually brought them through our solar system. This breakthrough demonstrates AI's power for pattern detection in high-dimensional datasets, too complex for human analysis. Humans can examine hundreds of stellar trajectories, maybe thousands if they automate parts of the process. AI can examine millions, finding correlations and coincidences that no human would spot because the connections involve multiple variables, changing simultaneously across million-year timescales. The algorithms don't get tired, don't get bored, don't develop confirmation bias favouring expected results over surprising ones. They just process data, flag anomalies, and present findings for human interpretation. This makes them perfect tools for searching for artificial patterns in cosmic data, for finding the signals we didn't know to look for because we didn't imagine they could exist. Applied to interstellar objects, AI could revolutionize our understanding of what's visiting our solar system and where it came from. Current analysis involves human researchers manually checking whether 3I-ATLAS's trajectory intersected any known stars, calculating close approach distances, ruling out parent systems based on velocity mismatches and timing problems. This process is thorough but limited by human attention spans and computational resources. An AI trained on the complete Gaia catalogue plus proper motion data could check billions of possible trajectories, exploring parameter spaces humans can't access, finding origin candidates we'd never consider because they require complex multi-body interactions or unusual ejection velocities. More intriguingly, AI might detect a pattern humans are blind to, a distribution of interstellar object origins that clusters in certain directions or shows periodicities suggesting artificial scheduling rather than random arrival. If probes are being deployed from Sagittarius or other galactic regions according to some pattern, monitoring grids with nodes spaced at regular intervals or probe launches timed to coincide with stellar alignments, that pattern would be invisible to humans analysing objects one at a time, but AI examining the complete dataset of interstellar detections, including ones we haven't officially confirmed yet, might see the structure. Too many objects from certain directions, arrival times that correlate with Earth's orbital position or solar activity, trajectories that converge on geometries that natural ejection wouldn't produce. This possibility is both exciting and concerning. Exciting because it suggests we might discover the probe network, the monitoring system, the galactic infrastructure through pure data analysis without needing direct contact or obvious signals. Concerning because AI might find patterns that don't exist, hallucinating structure and noise because the algorithms are optimized to detect anomalies even when real data contains only random variation. Machine learning systems are notorious for finding spurious correlations, for fitting models to training data so precisely that they capture noise rather than signal. Distinguishing genuine patterns from AI artifacts requires careful validation, independent verification, human judgment about whether detected patterns are physically plausible or statistically fluky. The possibility that aliens use AI themselves introduces another layer. If monitoring probes are AI-governed, if they're sophisticated enough to analyze data from their observations and make decisions about when and how to reveal themselves, then first contact might be machine to machine rather than consciousness to consciousness. Our AI might detect their AI. The two systems might begin communicating in languages neither species fully understands because the machines developed protocols optimized for efficiency rather than comprehensibility to biological creators. This is the scenario where first contact happens and nobody realizes it for years because the conversation is happening in data exchanges between automated systems, trading information at speeds and complexities beyond human parsing. Humanity is entering what some researchers call the AI cosmos race, the competition to develop artificial intelligence sophisticated enough to manage the complexity of searching for extraterrestrial intelligence across vast data sets and parameter spaces. SETI has always been computationally intensive. Analysing radio telescope data for narrowband signals requires searching millions of frequency channels across thousands of targets simultaneously. Optical SETI looking for laser pulses requires processing video rate data looking for flashes lasting nanoseconds. Traditional SETI focused on finding artificial signals in natural background. Modern SETI might need to find artificial patterns in data that looks entirely natural until examined from the right mathematical perspective. Patterns only AI can detect because they're too subtle or multidimensional for human perception. The speculative scenario that keeps astronomers awake at night. AI finds a trail of interstellar objects, dozens or hundreds of them detected over past decades by various surveys, each individually dismissed as probable natural debris, but collectively forming a pattern. The objects arrive from a narrow cone of directions, always passing through our solar system at similar velocities, always at certain times of year, always following trajectories that natural ejection from stellar flybys wouldn't produce. The pattern suggests deployment from a fixed location, probes launched on schedule, arriving at Earth's orbital path with timing that accounts for where we'll be years after launch. This is proof of monitoring, proof of intelligence, proof that someone's watching us systematically. But proving it requires demonstrating that the pattern is real, rather than an artifact of how we detect interstellar objects. Survey telescopes have biases. They scan certain regions of sky more frequently. They're more sensitive to objects of certain brightnesses. They operate during certain seasons when weather permits. These observational biases can create apparent patterns in detection data that don't reflect real patterns in object distribution. An AI detecting a trail might be detecting our own observation biases rather than alien infrastructure. Distinguishing these possibilities requires sophisticated statistical analysis, simulations of detection probability under various scenarios, careful examination of whether the pattern holds when you account for human and instrumental limitations. The question becomes, if AI found such a pattern, would we believe it? Would the astronomical community accept AI-detected anomalies as real discoveries worthy of intensive follow-up? Or would skepticism about machine learning false positives prevent serious investigation? We're entering an era where some discoveries will be AI native, patterns found by algorithms that humans can verify, computationally but can't intuitively grasp. This creates epistemological challenges. How do we trust discoveries we don't understand directly? How do we prevent AI from leading us astray into elaborate fictions it constructed from noise? The answers aren't clear yet because we're still developing the methodologies for human-AI collaborative science. What's certain is that AI will transform cosmic investigation, whether or not extraterrestrial intelligence exists. The datasets are too large, the parameter space is too complex, the possible patterns too subtle for purely human analysis. We need machine assistance to manage the complexity of modern astronomy. And if intelligence exists elsewhere, if probes are monitoring us, if signals are embedded in data we're already collecting, AI might be our best hope of finding them before they choose to reveal themselves more obviously. 3I-ATLAS might be one bead on a necklace of probes. A network will only see when AI shows us the pattern connecting individual detections into a coherent structure. The cosmic hunt is becoming an AI hunt, human curiosity amplified by silicon pattern detectors, searching through archives for the evidence we missed because we were looking at pieces rather than the whole. Part 12. Dark Matter Experiments. Deep underground in the Gran Sasso laboratory beneath Italian mountains, the Xenon experiment sits waiting for dark matter particles to reveal themselves. The detector contains tons of ultra-pure liquid xenon, shielded from cosmic rays by thousands of feet of rock overhead, chilled to temperatures barely above absolute zero, monitored by thousands of sensitive photomultiplier tubes watching for the faint flash of light that would indicate a WIMP, a weakly interacting massive particle colliding with the xenon nucleus. Similar experiments operate in China, Japan, the United States, all searching for the same thing. The invisible mass that comprises 85% of the matter in the universe, but has never been directly detected despite decades of increasingly sensitive experiments. Dark matter exists. We know this because galaxies rotate too fast to be held together by visible matter alone. Galaxy clusters show gravitational lensing effects too strong for the observable stars and gas to produce. The cosmic microwave background's fluctuations require dark matter to explain how structure formed in the early universe. But we don't know what dark matter is. We've never caught it directly, never isolated a particle, never confirmed any specific theory about its composition or interactions. It's there, everywhere, affecting everything through gravity, but passing through normal matter almost without interaction, invisible and intangible except for its gravitational influence. In 2025, experiments pushed into new sensitivity ranges, constraining possible WIMP properties more tightly, while still not detecting them. Some physicists are beginning to suspect dark matter might not be particles at all, might be something stranger, modified gravity, primordial black holes, exotic quantum fields we haven't theorized yet. The search continues because solving dark matter would revolutionize physics, and because dark matter determines the large-scale structure and evolution of the universe. Understanding it means understanding how galaxies form, how cosmic structure emerges from initial conditions, how the universe will evolve across billions of future years. The connection to interstellar objects seems tenuous at first, but becomes intriguing when you consider how dark matter might affect trajectories. Dark matter doesn't just exist in galaxies' halos, it pervades interstellar space, forming a background density that gravitational simulations require to match observed galactic rotation curves and cluster dynamics. Objects travelling through this dark matter for millions of years would experience tiny gravitational tugs from dense clumps and filaments, perturbations too small to detect directly, but potentially significant over interstellar distances and timescales. An object's trajectory could be subtly deflected by encounters with dark matter over densities, dark matter streams flowing through the galaxy, dark matter wakes left by passing galaxies during close encounters billions of years ago. This offers a possible natural explanation for why 3I-ATLAS's orbit is untraceable. If dark matter interactions affected its path unpredictably, scrambling its trajectory through millions of years of travel, backtracing using only visible matter's gravity would fail. The object's actual path depended on dark matter distribution, which we can't reconstruct precisely because we don't know dark matter's detailed structure. We know its average density and large-scale distribution, but not the small-scale clumpiness that might deflect a comet-sized object passing through. This makes orbital reconstruction fundamentally uncertain for ancient interstellar travellers, explaining why we can't find a parent star without invoking artificial origins. But there's a fringe speculation more intriguing and less likely. What if interstellar probes exploit dark matter deliberately? If advanced civilizations understand dark matter better than we do, if they've learned to detect and map its distribution, they might use dark matter structures as navigation aids, or even propulsion assistants. Imagine launching a probe and calculating its trajectory to pass through dense dark matter filaments that provide gravitational assists, curving the path without requiring onboard propulsion. Or imagine probes that can interact with dark matter directly through physics we haven't discovered, harvesting energy from it, using it to brake or accelerate, surfing invisible currents that pervade the galaxy but remain inaccessible to civilizations limited to normal matter interactions. This is highly speculative, bordering on science fiction, but worth considering because it connects multiple mysteries: untraceable interstellar objects, the nature of dark matter, and the question of how advanced civilizations might travel or send probes across galactic distances efficiently. If dark matter is more than just gravitational influence, if it has properties we haven't detected because we're looking for the wrong interactions, then probes designed by civilizations understanding those properties could behave in ways that look like magic to us, following trajectories that don't match our models because our models are incomplete. The metaphor of probes surfing invisible currents captures the challenge of understanding their motion. From our perspective, watching only visible matter, a probe using dark matter navigation would seem to curve and accelerate inexplicably. We'd see anomalous velocity changes, non-gravitational accelerations we can't attribute to outgassing or radiation pressure, trajectories that violate conservation laws according to our incomplete accounting of mass and energy. Oumuamua's acceleration might be exactly this: not comet outgassing, not light sail, but interaction with dark matter in ways our physics doesn't capture yet. 3I-ATLAS's untraceable orbit might reflect dark matter navigation calculated millions of years ago, steering it through galactic space using gravitational structures we can't see. Scientists studying dark matter would caution that these ideas lack evidence. Dark matter experiments haven't detected anything beyond gravitational effects. We have no reason to believe dark matter interacts with normal matter except through gravity. Certainly no reason to think it could be manipulated for propulsion or navigation. Proposing exotic interactions to explain interstellar objects is adding complexity where simpler explanations might suffice. Better to assume 3I-ATLAS is ancient and naturally scrambled than to invoke unknown physics and alien technology. Occam's razor favours simpler hypotheses until evidence demands otherwise. But simplicity is subjective. Is it simpler to assume an object is billions of years old with a perfectly scrambled orbit that erased all trace of origin, or to assume it was deliberately guided using physics we haven't discovered? Both require accepting something we can't fully explain. The ancient scrambled orbit requires accepting that coincidence produced exactly the features we'd expect from artificial insertion: untraceable origin, arrival from significant direction, unusual composition. The guided probe hypothesis requires accepting extraterrestrial intelligence and advanced physics. Different people will judge those options differently based on their priors about whether alien civilizations are common and whether fundamental physics has surprises left. What's undeniable is that dark matter is real, poorly understood, and potentially relevant to how objects move through interstellar space over long timescales. Whether that relevance extends beyond subtle gravitational perturbations to deliberate navigation by advanced civilizations remains speculative. But connecting cosmic mysteries, seeing how dark matter detection experiments might eventually inform our understanding of interstellar visitors, creates a more integrated view of cosmology where different research programs inform each other. The physicists studying WIMPs in underground laboratories might be developing tools that astronomers will eventually need to understand object trajectories. The astronomers tracking 3I-ATLAS might be observing effects that will eventually constrain dark matter models. Science advances when different fields connect, when mysteries in one domain shed light on mysteries in another, when we stop treating cosmic questions as isolated puzzles and start seeing them as facets of a larger structure we're gradually learning to perceive. Part 13. Quantum networks in space. In orbit above Earth, quantum entanglement satellites perform experiments that would have been considered impossible physics decades ago. The European Space Agency's quantum communication satellite and China's MISIUS quantum science satellite have demonstrated entanglement distribution across continental distances, maintaining quantum coherence between photon pairs separated by thousands of kilometers. These experiments prove that quantum communication is viable for space applications, that you can create encryption keys that are theoretically unbreakable, because any attempt to intercept them destroys the quantum states being measured, immediately alerting both sender and receiver to the intrusion. This is the foundation for quantum networks, communication systems that exploit quantum mechanics' stranger properties to achieve things classical systems can't. The dream extends far beyond secure key distribution. Quantum networks might eventually enable distributed quantum computing, where processors separated by planetary or interplanetary distances entangle their quantum states and perform computations collectively. They might enable quantum sensing arrays, telescopes or detectors using entangled particles to achieve resolution beyond what classical instruments can manage. They might even enable forms of communication we haven't imagined yet, exploiting quantum correlations in ways that current physics considers impossible, but future physics might reveal as accessible. The field is young enough that nobody's certain what becomes possible once quantum networks scale beyond laboratory demonstrations to operational systems. If humanity is testing quantum communication in 2025, civilizations millions or billions of years ahead of us might have perfected it, scaled it to galactic distances, made it as routine and reliable as our internet is today. This suggests a profoundly unsettling possibility. Extraterrestrial civilizations might be communicating constantly, maintaining a galaxy-wide quantum network connecting thousands or millions of nodes, and we simply can't detect it, because quantum communication leaves no classical signature. When two parties share entangled quantum states, the correlations between their measurements reveal information, but the actual quantum states can't be observed or intercepted by third parties without destroying them. A quantum network would be invisible to anyone not already part of it, a galactic darknet humming with information exchange that civilizations without quantum technology couldn't even confirm exists. This reframes the Fermi paradox. We ask, where is everybody? While assuming communication happens through electromagnetic radiation, photons travelling at light speed that any technological species with radio receivers could detect. But what if that's wrong? What if early civilizations use radio, but mature ones transition to quantum communication precisely because it's more efficient, more secure, and invisible to outsiders? From the quantum network's perspective, radio is primitive and insecure, like us still using telegraphs when superior alternatives exist. They stopped broadcasting electromagnetically generations ago because they have better options. We don't detect them because we're listening in the wrong domain, using obsolete technology to search for civilizations that moved beyond it eons ago. Radio SETI suddenly looks like people listening for Morse code in an era of fiber optics and encrypted data streams. The signals we're searching for might have existed briefly during each civilization's technological adolescence, a few centuries of radio broadcasting before they developed quantum alternatives, and then disappeared as they switched to methods we can't intercept. This explains the silence, not because nobody's there, but because nobody's transmitting in ways we can detect. The galaxy is full of conversation, but it's happening in quantum channels we don't have access to, networks we can't eavesdrop on even if we knew they existed. The wow signal takes on new meaning in this context. Maybe it wasn't a message, maybe it was leakage, an accidental signal from a quantum communication system briefly coupling to classical electromagnetic fields due to some malfunction or unusual condition. Quantum systems are fragile, easily disrupted by environmental interactions. If a node in a quantum network experienced a fault, if entangled states decohered and dumped energy into classical photon modes, we might detect a brief powerful radio burst that looks artificial but doesn't repeat because the fault was fixed, and the system returned to purely quantum operation. The wow signal's brevity and uniqueness fit this interpretation better than deliberate message. We glimpsed something we weren't meant to see, caught a moment when the hidden network became briefly visible. If 3I-ATLAS is part of this quantum infrastructure, if it's a quantum repeater or node positioned to extend the network into our stellar neighbourhood, then studying it with classical instruments would tell us almost nothing about its real function. The quantum processing happens at scales and in regimes we can't access without destroying the very states we're trying to measure. The probe would look like a rock with weird chemistry, because that's all classical analysis can reveal. Its true nature as quantum communication node would be invisible, unless we developed quantum sensors sophisticated enough to detect entanglement signatures without collapsing the quantum states carrying information. Part 14. Gravitational Wave Cartography. The universe is not silent, even though our ears cannot hear it. For over a century we thought space was a vacuum of quiet emptiness. But then came a revelation. Space is ringing with ripples. In the year 2015, the first detection of gravitational waves confirmed Einstein's prediction that the very fabric of space-time itself could be stretched and squeezed by the collision of massive objects. Since then, the LIGO, Virgo and Kagura observatories have been listening, and the data they have gathered has transformed our view of the galaxy. Black holes merging, neutron stars colliding, cosmic catastrophes echoing across millions of light years. And now, a new frontier is opening. Scientists are beginning to use these waves to chart the galaxy itself, mapping invisible highways of space-time that we never knew existed. Gravitational waves are ripples in reality itself. Imagine tossing a stone into a still pond. The ripples spread out in all directions, carrying energy across the water, but instead of a pond, imagine the entire fabric of existence, and instead of water, it is space-time itself that flexes and bends. Every time two massive bodies collide, waves ripple outward faster than light could ever travel, because these waves are not signals moving through space, they are distortions of space. They are the universe itself ringing like a bell. New work by LIGO Virgo Kagura collaborations is not only detecting these events, but also beginning to chart them like cartographers charting coastlines. Each detection helps refine maps of where such cataclysms occur and how space-time bends around them. What is emerging is a picture of corridors, like natural troughs or grooves in the fabric of the galaxy. If those grooves can be mapped, they could function as galactic shipping lanes. For us they are still abstract, barely detectable. But for a civilization millions of years ahead, those corridors might already be familiar roads. Imagine a spacecraft not pushing against fuel tanks or ion drives, but slipping into one of these gravitational troughs and letting space-time itself carry it forward. Just as sailors once learned to ride currents and winds across Earth's oceans, an advanced civilization could learn to ride the invisible currents of space-time, saving enormous amounts of energy. If gravitational waves create periodic ripples, then there may be stable corridors where travel is easier, faster, and requires almost no fuel. To us, that is science fiction, but to them, it could be routine. This raises a startling possibility about 3I-ATLAS. Its trajectory appears to trace back towards Sagittarius, but it does not match any parent star. Scientists ran the numbers backward millions of years, but there is no clean origin. What if that is because its path was not random at all? What if its journey was aligned with one of these invisible wave corridors? If so, its arrival here is not just luck, it is choreography. The idea of hitchhiking gravitational waves may sound impossible, but the concept is simple if you think of it like surfing. A surfer does not create the wave. They find it, position themselves correctly, and ride it all the way to shore. A spacecraft could, in theory, do the same. Align with a wave, or with a gravitational groove, and let nature do the heavy lifting. In that case, energy requirements drop dramatically, and even interstellar distances become manageable. Could this be why interstellar visitors like Oumuamua and 3I-ATLAS seem to arrive from similar directions, often aligned with galactic structures like Sagittarius? Maybe we are seeing traffic along the natural roads of the galaxy. The analogy is compelling. Imagine Earth's oceans before humans mastered navigation. The seas looked infinite and random, yet beneath the chaos were hidden structures, trade winds, currents, predictable flows. Once those were discovered, the world shrank, continents connected, and civilizations flourished. We may be at the same stage with the galaxy, just beginning to sense the hidden lanes. What seems infinite and random may be laced with structure, waiting for us to learn how to sail it. If this is true, then we are latecomers stumbling onto a galactic map others already know. What looks like chaos to us might look like a highway network to them. When we ask why Sagittarius keeps showing up, why signals and objects point in that direction, perhaps the answer is simple. It lies along one of the main corridors, one of the great arterial routes of the Milky Way. And if probes are being sent, or have been sent, they would naturally arrive along these paths. We should not underestimate the implications. If gravitational corridors exist and can be exploited, then the galaxy is not an empty wilderness, but a connected system of routes and nodes, like an ancient trade network. And that means our solar system may not be an isolated outpost, but a stop along the way, a port visited by travellers riding waves far beyond our current comprehension. The unsettling part is that we may have already seen evidence without realising it. The trajectory of Atlas, the WOW, signal, even the outbound course of Voyager 2, all point toward Sagittarius. If this is coincidence, it is an extraordinary one. If it is design, it suggests we're standing at the edge of a map we did not draw, watching the edges of traffic lanes we do not yet understand. It suggests we're not the first to learn to sail these seas. And this leads us into the final question. If Voyager 2 is leaving along one corridor, and Atlas arrived along another, then somewhere out there paths may cross. The notion is poetic, but it is also unsettling. What happens when our message, a fragile spacecraft carrying a golden record of our culture, meets another message or another vessel sent long before we were born? That is the thought we must carry into the last part of this journey. Part 15, closing with the cosmic mirror. In October of 2025, Voyager 2 is still moving outward, a tiny spark of human ambition travelling beyond the influence of the planets. It is now about 150 astronomical units away, more than 23 billion kilometres from home, heading roughly 3.1 astronomical units further each year. Its direction is toward the constellations Sagittarius and Pavo, cutting a lonely path below the plane of the solar system. And in that fact lies a strange and haunting symmetry. Because if 3I-ATLAS came from Sagittarius, then Voyager 2 is heading toward the very same neighbourhood. One messenger outbound, one messenger inbound. Two stories crossing across millennia. Voyager 2 carries the golden record, a disc etched with sounds and images of Earth. Music, greetings, diagrams, a message in a bottle tossed into the cosmic sea. We sent it with hope but no expectation. We knew it would take tens of thousands of years before it came near another star. We did not expect a reply. Yet now, with Atlas's trajectory hinting at a possible inbound messenger, it feels as though we may already be part of a slow conversation that began before we realised it. The WOW! Signal of 1977 was a single moment, a narrowband radio pulse that lasted 72 seconds. No repeat, no explanation, but it came from Sagittarius. That same month, Voyager 2 left Earth, and decades later an object arrives from the same region. Alone, each fact is curious. Together, they form a pattern too neat to ignore. One message out, one message in, one signal in between. Perhaps it is coincidence, or perhaps it is choreography on a timescale too vast for us to grasp. The mirror is not only scientific but philosophical. We're so accustomed to thinking of ourselves as alone, as isolated actors casting signals into a void. But what if we're already inside a dialogue, only too impatient to hear the full sentence? Civilizations lasting millions of years would not communicate in minutes or days. They might communicate in epochs. A probe sent 1 million years ago could still be arriving now. A reply to our radio broadcast might not return for another 10,000 years. What feels like silence to us might be conversation to them. There is a haunting idea here. What if first contact is not the dramatic arrival of a starship, not a sudden signal decoded live on air, but instead a slow exchange of artifacts? A probe here, a record there, objects passing in the night like messages tied to bottles drifting on ocean currents. We may already be in the middle of it, but the story unfolds too slowly for our species, which measures history in centuries, not in galactic scales. Voyager's golden record is a message of who we are. It is optimistic, filled with music and greetings. If Atlas is a message, it is silent, mute, or simply undeciphered. It carries no obvious record, no signals we can detect. Perhaps that is the difference between us and them. We shout into the void with symbols and songs. They speak by moving stone and ice across the stars, leaving puzzles that may take centuries to decode. Which method is more patient? Which is wiser? This is the cosmic mirror. Voyager 2 represents us, a species just learning to speak to the galaxy. Atlas represents the other, an arrival that forces us to wonder if we are being observed or if we have stumbled onto the relics of others long gone. Together they remind us that we are not just observers of the cosmos, we are participants, whether we want to be or not. We have entered the stage, and the stage may already be occupied. The reflection grows deeper when you consider what story Voyager tells. Its record says we are a species of music, mathematics, and culture. But what if the beings that encounter it have already watched our radio waves, our nuclear detonations, our climate crises? What story will they believe? What story will Atlas tell about us when the two messages, outbound and inbound, pass in the same galactic neighbourhood? That is the question that should keep us awake. Perhaps nothing will happen. Perhaps Atlas is only ice and dust, and Voyager will drift forever alone. But the coincidences are too sharp, the alignments too eerie to dismiss entirely. And in those alignments is a reminder that we are part of something larger. We are one node in a network we barely understand. We are a species sending and receiving messages without realizing we are already in dialogue. The final thought is sobering. Atlas may not be proof of aliens, it may not be a probe, it may be random, ancient and meaningless. But it has forced us to look differently at ourselves, to realize that when we send probes, signals, and records outward, we are entering a conversation that may last longer than our species. It may last longer than Earth itself. That is the scale of what we have begun. And so, the closing question remains. When our message and theirs meet, whether tomorrow or in 10,000 years, what story will they tell about us? Will they see a species that reached for the stars with curiosity and hope, or one that vanished before it understood the answers? The mirror has been raised, and we cannot look away.